All right, question number 5. It says, can the graph of a polynomial have a vertical or horizontal asymptote? Explain. So a polynomial, let's just review. A polynomial is just one term. It could be, 5, or it could be x, or it could be sum of multiple polynomials added and multiplied together. So let's just say 2x squared plus 3 minus 4. So something of this form. Won't have anything in the denominator, so no negative exponents, no fractional exponents. You could have a number, like let's just say, okay, we can have something like this, but we won't have any variables in the denominator. So there will be no restrictions. Polynomials, domains are all real. So therefore, there won't be any vertical asymptotes. There's no numbers that when we plug in 0 will cause this to break down. No horizontal asymptotes. So we will say no, it cannot have horizontal or vertical asymptotes if it's a polynomial. And then let's find the one that best describes that. So we got 3 options. Because the domain is 0 to infinity, I'm going to say that's wrong. It's going to be negative to positive. Because the domain is negative to positive infinity, there aren't any vertical asymptotes. And the limit as p of x, as x goes to positive or negative infinity, is equal to positive or negative infinity, there aren't any asymptotes. So yes, that would be the case. The end behavior continues to go toward infinity. So B looks like the answer that best matches. Alrighty. All right, number 6, it wants us to describe the possible end behavior of the polynomial. All right, so for any polynomial, just kind of as a review, you can have even degree or you have odd. And then based on even or odd, you have either it's positive or it's negative. All right, so if you have an even degree and it's positive, both the ends will go to positive infinity. If you have even and it's negative, both ends will go down to negative infinity. If you have an odd degree and positive, right side goes to positive, left side goes to negative. So that's the right side is positive, goes up to positive, left side is negative, goes down to negative. If you have odd and negative, it flips. So the left side goes up to positive. So the negative side of the graph left goes positive infinity. The right side of the graph, which is positive side, goes down to negative infinity. So this is the end behavior. This is what we're referring to. All right, so as it says, for an even ordered polynomial. So we're talking about even. Either the limit as the function goes to negative infinity equals positive, and the limit as x goes to positive is equal to negative. So that will not work, because when we are talking about even degree, both ends go positive or both ends go negative. So right there, that disqualifies that statement. Even ordered polynomial, f of x as we go to negative infinity is positive, as we go to positive infinity is positive, or as we go to negative infinity is negative, or as we go to positive infinity it is negative. So B looks good for an even ordered. And then it says for odd, either the limit is as x goes to negative is going to be positive. So that would be this case, negative goes to positive, and as x goes to positive, it goes negative, or negative to negative and positive to positive. So this looks really good. That matches the statement of polynomials in end behavior.